Satyabama Institute of Science and Technology.
Myself, Dr. Ebenezar Jebarani, Professor, Department of ECE, Satyabama Institute of Science and Technology, Chennai. So, in this video lecture, we are going to discuss how to control the speed of the motor with the help of 8051 microcontroller. First of all, we know that what is DC motor. DC motor is nothing but direct current motor, and it is a type of electrical machine which convert the electrical energy into mechanical energy. DC motors take electrical power through direct current and converts this energy into mechanical rotation. So, we are going to see the block diagram of the how to interface the DC motor. So, this is the block diagram of interfacing the 8051 microcontroller with DC motor. So, first of all, we are going to see that we are having a tacho-generator which will be controlling the or measuring the speed of the motor. So, the speed of the motor will be measured by the tacho-generator, and that signal will be a analog signal. So, that analog signal will be converted into analog signal will be amplified as well as it will be boosted so that it can be able to recognized by the analog to digital converter. So, the signal conditioning circuit, what it will be doing means it will be amplifying the signal. So, that signal will be a analog signal which is an amplified signal. So, that signal will be given to a analog to digital converter. So, the analog to digital converter, what it will be doing means it converts the analog signal to digital, because microcontroller will know only to process the digital data. So, the analog to digital converter, what it will be doing means when we are giving a start of conversion, so it will be start converting the analog signal to digital signal. So, once the conversion started, the microcontroller will be waiting till it receives the end of conversion. Once it receives the end of conversion, the data will be received through port B of 8255. 8255 is nothing but the programmable peripheral interface. With that, we are just getting the data to the microcontroller. So, the microcontroller receives and it will be calculating the speed of the motor, and it displays the speed of the motor. Once the motor speed is displayed, the operator will be entering the data through the keyboard what should be the desired speed. Because we are going to control the speed of the motor, we are going to enter the desired speed. So, the operator will be entering the desired speed through the keyboard. So, once the actual speed is displayed, the desired speed and the actual speed will be compared, and if the actual speed is lesser than the desired speed, we have to increase the speed of the motor. If the actual speed is greater than the desired speed, we have to decrease the speed of the motor. If both the speed are same, we no need to do any operation, let it be continuing in the same speed. So, this is the operation to be performed. So, how it should be achieved? For that, we are having actually a calculating the error signal. So, the error signal will be calculated, which will be a digital signal, but to control the armature voltage of the motor, we need the analog signal. So, again the reverse process, digital to analog conversion will be done, and that conversion will be that analog signal which is to be controlled the firing angle of the SCR, and that SCR will be controlling or generating a signal to control the armature voltage. Either it will be increasing the speed of the voltage or decreasing the speed of the voltage depending upon the speed of the motor what we need as per the desired speed. If it is actual speed is lesser, then we have to increase the speed of the motor. If the actual speed is more, then we have to decrease the speed of the motor. So, that will be done with the help of the adjusting the firing angle of the SCR, which is supplied to the armature voltage. So, this is the function of your DC motor speed control. So, in this we are having actually a 8279, which is nothing but the keyboard / display controller, and we are having the memory, RAM memory as well as ROM memory, and we are having a display unit here to display your speed. So, this is the actual block diagram of your DC motor interfacing. So, the same thing was explained here. The speed of the motor will be received through the tacho-generator, and then the analog signal will be scaled to a signal conditioning circuit, and it will be boosting up the signal, and we are going to perform the conversion here, analog to digital conversion, so that the data can be calculated, the speed of the motor can be calculated, and it will be processed by the microcontroller. Then the digital data received is proportional to the speed, and we are displaying the speed, and we are just comparing the actual speed and the desired speed. And what I had told, I am just repeating for recollecting. Then we are calculating the error, whether to increase the speed or decrease the speed. So when the actual speed is NA and desired speed is ND. When NA is less than ND, then increase the speed. When NA is greater than ND, then decrease the speed. When NA is equal to ND, repeat the steps above continuously. This is the operation of the speed control of DC motor. This is the flow chart here. So in this flow chart, we are just initializing the 8255 programmable peripheral interface, as well as we are initializing 8279 keyboard bar display controller. Then we are getting the desired speed from the operator. So once the desired speed is received, we calculate the actual speed here, which will be the received from the tacho-generator, and that speed will be given to the data will be given to an analog to digital converter, where we are giving the start of conversion and waiting for the end of conversion. When we received the end of conversion, the data will be read through port B of 8255 to the microcontroller, and we are calculating the actual speed here, then display the actual speed, and we are checking whether it is greater or smaller or equal to. So if it is lesser, as per that, it will be generating a necessary error signal, and it generates a necessary control signal to vary the armature voltage to increase the speed or decrease the speed. This is the process we are seeing here. Already we discussed that one, where we are going to use this DC motor. The application of the DC motor, everyone in our day-to-day life real-time applications, we are using this one. It is actually used in lathe machine, drilling machine, then grinders, blowers, as well as compressors. So it is nothing but limited to this. It is more and more applications are available. So with this, I conclude this lecture. Thank you so much.